So we've spoken about classes, objects, constructors and data classes. But all the classes we have seen were all mutually exclusive. That is, two classes were independent of each other. So we can say that we have seen objects depend on classes, but we haven't seen classes depend on other classes. But now we are going to look at classes that depend on other classes. Now earlier we had seen a class called dogs, and its objects were dogs of different breeds. But now let's say there is another class called cats. Now the properties of class dogs is that they have a tail, 4 legs and fur. The properties of class cats is that they have a tail, 4 legs and fur. So they both have the same properties. But now let's look at their behavior or functions. So the functions of class dogs is that they eat, sleep and bark. And the functions of class cats is that they eat, sleep and purr. So you see that these two functions are common to both the classes and these two are different. So when we will create the classes for each, we will have to create these two same functions twice. Now to avoid doing rework, what if we can create another class that can have these two functions that are common to both these classes, and then these classes can use these functions? Wouldn't that save a lot of work for us? Yes, it would. And so we have the concept of inheritance in Kotlin and other object-oriented programming languages. So we can create another class called animals here. Now let's simplify this chart and remove the extra elements. So we can have the class animals, and this class can have these two common functions, eat and sleep. And these two classes, dogs and cats, can then have just these two functions, bark and purr. These two classes can then use the common functions from the common class animals. This class that has the common functions is known as the parent or base class or superclass. And these two classes which will use the functions from the parent class are known as the child class or derived class or subclass. So the child class inherits the functions of the parent class. Now let's define inheritance. Inheritance is one of the key concepts of object-oriented programming. It enables reusability, that is, it allows a class to inherit features, properties and behaviors from another class. The class that inherits the features is called the child class, and the class whose features are inherited is called the parent class. So for class dogs, we inherit all the features of the class animals and create another function called bark. And for class cats, we inherit the features of the parent class animals and we create another function called purr. This makes our code cleaner, understandable and extendable. Now, one thing that is important to remember is that when we create parent and child classes, each child class should be able to satisfy this condition. Child class is a base class. So for example, we can say dogs are animals and cats are animals. Any child class that cannot satisfy this condition will not be a child class of that base class. So remember to say this in your head while you are thinking of parent and child classes. That's all for this video. Click next to learn more about inheritance. Now let us look at the syntax for creating parent classes. So this is the syntax for creating a parent or base class. We start by writing the keyword open, then we write the keyword class, and then the name of the class starting with a capital letter. Inside these parentheses, we have the properties of the base class and the body inside these curly braces. It's the same as creating a class, just that we have the keyword open in front of a parent class. The keyword open allows this class to be reusable. This is how we will define the parent class animals. Now let us look at the syntax for creating a child class. This is the syntax for creating a derived or child class. We write the keyword class and then the name of the class starting with a capital letter. Now inside these parentheses, we have the primary constructor of the derived class, where we initialize the properties of the base class as well as the properties of the derived class. After this, we use the colon, and then we write this to inherit the properties of the base class. So we write the name of the base class and its primary constructors. Now, this is how we can define the child class dogs. Notice that while writing the primary constructor here, we do not use the keywords var or val for properties of the base class. And while inheriting the base class here, we only write the names of the properties and not the data types. Now let's go to the IDE and create these classes. So let's first create a new project in IDEA like this. Then let's create the main file and the main function. And then let's create a new KOTLIN class called animals. Now let's define the parent class animals like this. Then we will create two functions here called eat and sleep. Now let's create a new class called dogs. Let's define the child class dogs like this. Then we will create the function bark. Now let's add another child class called cats. Let's define this class like this. And then let's create the function purr for this class. Now that we have created all our classes, let's go back to the main function and create objects for the two child classes. So we will create this object of the child class dogs and pass the parameters here. We call the two functions of the parent class and the function of the class dogs here like this. Now let's do the same for the child class cats. So we have been able to use the functions of the parent class animals in both these child classes, right? So this was the output we got in the previous video. Now if you see, we have been able to reduce our work by creating a parent class and using its two functions for the two child classes. But we still had to create two independent functions for bark and purr separately in both the child classes. Won't it be great if we can define these functions also just once and reuse it? What if we can create a function called sounds in the parent class and then reuse and modify it to specify the sounds made by the two different animals? Wouldn't that make our task simpler? Especially more for long programs where we may have many child classes and a lot of functions. Moreover, we won't have to remember the names of all the individual sound-related functions in such a case and we can simply use one function name called sounds. So let's see how we can do it. So here, let's first create a function called sounds like this. Notice that we have used the keyword open before this function name because the child classes will call and modify this function, and so it needs to be declared open to enable reusability of the function. We were also using these other functions in the child classes, but since we did not need to modify them, we did not use the keyword open while defining them. Now let's go back to the main function and remove these functions and call the function sounds in both the objects. So, as you will see, when we use the functions as it is, we get the output, I make a sound. But we do not want to print this. We want the function to be customized according to the child classes. So let's go to the child class dogs and create the function sounds and give it a new customized message. Now if you see, there is some error being shown by the IDE on this function name. Let's hover over it to see what the IDE has to say. So the IDE says that sounds hides the member of supertype animals and needs an override modifier. What this means is that the name of the function used in the parent class and the child class is the same. So we can either change the name of the function or we can add the keyword override before the function definition. Since we are referring to the same function and we want to use the same name, let's add the keyword override before this function definition. If you will see, the error is gone now. Now, let's do the same for the class cats. Now let's run the program again. Yes, we get the customized outputs now. So, what we have looked at here is a way to inherit methods or functions defined inside the parent class. Now if you notice, we are using the terms functions and methods interchangeably. So don't get confused if we use one instead of the other. That was all for this video. In the next video, we will look at visibility modifiers. So let's talk about visibility modifiers now. First, let's understand what the term visibility means here. So, visibility in terms of programming means accessibility. Hence, visibility modifiers are keywords that help us set the visibility or accessibility of variables, functions, classes, objects, constructors, properties, etc. Let's look at an example to understand this. So when we say this particular variable A is not visible inside this function B, we mean that the function B cannot access variable A. Hence, it cannot use variable A. It's a simple concept really, and we have already discussed it in brief when we learnt about the scope of a variable. Now there are 4 types of visibility modifiers in Kotlin. These are public, private, protected, and internal. We will look at each one of them in detail. So let's start with public. Anything declared public is available everywhere in the project. It's just like we think of the word public in our everyday lives. The default visibility for everything is public. Now let's go to private. So, a top-level function or class that is declared private can be accessed only within the file where it is declared. A top-level function is any function defined outside the main function. All the functions that we learned to create before we came to classes were all top-level functions. Also, any member function, constructor, or property declared private can be accessed only inside the class where it is declared. Next, let's come to protected. So, any property or member function declared protected is visible or accessible only within the class and its subclasses where it has been declared. A top-level function cannot be declared protected. Only properties or member functions of a class can be declared protected. Now let's come to internal. Anything declared internal is accessible only within a module. A module is a set of files compiled together. Now that we know the scope of each type of visibility modifier, let's go to our IDE to implement them practically. Now, let's create a new file called functions and create 4 functions with different types of modifiers. Let's create a public function that calculates the sum of integers a and b, then a private function that calculates the difference of a and b. Next, we create a protected function that calculates the product of a and b. And finally, an internal function that calculates the division of a by b. Now here if you see, the function product gives an error, since the modifier protected is used only for member functions or properties inside a class. And since we have declared it as a top-level function here, it is throwing an error. So let's comment out this function here. You can also use the shortcut Ctrl+Shift+\/ after highlighting the multi-line statements that you want to comment out. Now, let's create another file called main and let's create the main function here. Now let's call the 3 functions we created earlier. So here, we have called all the 3 functions. Now if you see, the functions that were declared public and internal are fine. But the function difference that was declared private is throwing an error here, because private functions are available only within the file where they are declared. And since we are using this function in a different file here, it is throwing an error. So let's comment this out as well. Now, since we cannot have a protected function as a top-level function, now we have learned about inheritance. But in Kotlin, a child class can only inherit from one parent class. So then, what do we do when we want a child class to inherit from multiple classes? We use interfaces in such cases. Now let's look at some features of interfaces. Interfaces are similar to classes, but they do not have a state or properties. So, they do not have constructors as well. They can have functions with or without default implementations. That is, the function definition may not necessarily have to be there. They are declared by using the keyword interface. Now, let's go to our IDE and create a new interface called MyInterface. So let's right-click on the src folder and then select New, and here let's select Kotlin file/class. Now in this dialog box, select Interface from this drop-down menu and give it the name MyInterface here. If you see, just like classes, the name of an interface also starts with a capital letter. So, the interface has been created for us. Now, as we said, it will not have any constructors, so no parentheses required. Then we have the curly braces. Now here, let's create 2 functions called hello and greeting. Since it is not necessary to give the default implementation of a function in interfaces, let's leave this function hello without a body here. we will give the default implementation for this function greeting. So, we have understood that a function body is called its default implementation. And we may or may not have a default implementation for a function in interfaces. Now, let's talk about inheritance in interfaces. So, when we talk about interfaces, we do not call it inheritance, but we call it implementation. The different term is used only to avoid confusion. The concept remains the same. Now, let's create a class called callMe and implement the interface we created. So this is how we will do it. It's just like inheritance. Now, before we proceed, you can see that the IDE gives an error here. This is because the function hello in the interface was not defined. So let's call the function hello and define it. As you will see, we have used the keyword override here since we are overriding that function here. If we want, we can also override the function greeting and change its definition here like this. Now let's go to this main function and create objects of class callMe and use the functions hello and greeting. Now, as we said, interfaces are used to solve the problem of multiple inheritance. So a child class can inherit multiple interfaces. So now, let's create another interface called new interface. Now let's create a function here. Now, let's go to the class callMe and implement this other interface. We can simply add the name of the interface here and it's done. Now let's use the function declared in the new interface and give its definition. Let's go to the main function now and add the new method here